4, longest rectangle in histogram. We are giving a histogram like this, and we are going to calculate the longest rectangle in the histogram. So for example, this area, the area is 10, which is the longest rectangle. Or maybe we can also find some other areas, like from here, this 5 and 6. So it is 2 times 5, it is also 10. So this is also a possible result. Yeah, maybe if this is 6, so it's going to be 12. So it's going to be the longest result. Yeah. But for such problem, how can we solve it? So we are giving a height array, and inside it's going to be numbers. It represents the height. So in this histogram, we're going to calculate the longest rectangle. So normally the rectangle would be connected. So for example, this 5 and 6, it is connected. It can become the longest. So for example, this 2, 5, and 6 is also connected from here. Maybe from here, yeah. So this areas. So for example, this areas may be the longest. It is 8, but it is not. Yeah. But how can we check all those combinations? I mean, it can be here like a single one, or it can be 2 or 3 or 4. So if we want to check all the combinations, we want to use a data structure to solve it. Let's check the number of the histogram. So the length is 10 to the power of 5. Yeah. So this means we're going to use ON, or n log n time, to solve the problem. So for such problem, we can use ON time. Yeah, because we can use a monotonic stack. So normally, if the histogram is increasing, it is okay. Yeah. But if the histogram is decreasing, yeah, if it is decreasing, we can calculate the longest square. So for example, if from here there is decreasing for this histogram, yeah. So yeah, so if this is a histogram, if it is decreasing from here, and now I will make a drawing to make it more readable. Yeah, maybe from here it is higher, here smaller, and smaller. Yeah. So up to this position, so it is always increasing, it is okay. But up to here, if it is decreasing, we're gonna use a monotonic stack. So it's gonna be a monotonic increasing stack. If it is increasing, it is okay. I gonna, for example, this is 2, 3, and this is 4, and this is 3. Yeah. So if it is increasing, it is okay. I can put it inside because I don't need to calculate the square yet, the rectangle square yet. I can put it inside my stack. So it's gonna be 2, 3, and 4. Now I need a 3. It is decreasing, so I need to pop out something. Yeah, I need to pop this 4 out. So I pop 4 out, and I get a square area. So the area gonna be 4. Now I'm gonna compare this 3 and this 3. Yeah. So if it is decreasing, I'm gonna pop out. Now it is still okay, so I'm gonna keep it. So currently it's gonna be something like this. Yeah. So here I have a 3. Here I have a 3 inside my stack. So now I don't have this 4. I have 3 inside my stack. Yeah. Currently I have an area of 4. Now what if I have 2? So what's gonna happen? So if I have 2, definitely I'm gonna pop out this 3. I have an area of 3. 3 is no bigger than 4. It is okay. But definitely I will pop out another 3. So if I pop out another 3, I can calculate the area. It's gonna be 1, 2, 3, 4. 4 times 2, it's gonna be 8. So my result would be updated to 8. Yeah, because even though I popped like 1, 2. Actually, this one has already been popped. I can use the index. So for example, if this index is 1, 2, 3, 1, 2, 3, 4, this index would be 4, and the area, yeah, I don't need to calculate this yet. The area is 6, it's not 8, yeah, because this one is not popped out. If I pop out something, I need to calculate the area because I popped those two out. So this is still 2. It is okay. So the result is 6. But as you can see, it should not be 6. The result should be 8. Yeah. So this means at the end of the heights, we need to prepare another value. Maybe it is a 0, or maybe it is a -1. It is okay. So if I set it as a 0, so for example, for the next value, it is a 0 from here. Now I need to pop it out. Yeah. Before, I already popped out those 3, and I put 2 inside. I have 2. 1, 2 is at index 0. Another 2 is 1, 2, 3, 4 at index 4. Now I need to pop out this first 2. Yeah. So I'm gonna get an area of 2. It is no bigger than 6. It is okay. Yeah. Now I want to pop out this 2 because it is bigger. So from here, this is the index 0, and this is index 4. So 4 minus 0. So it's gonna be 1, 2, 3. Yeah, 1, 2, 3, 4, 5. Yeah, it's gonna be 10. So currently, the area would be 10 because I popped out this one, I popped out this one, and in between there are also 3. Yeah, why I can do it like this? Because it is a monotonic increasing. If it is increasing, it means if I pop out a value, it is always bigger than 2, bigger than or equal than 2. So it means the final result would be 10. I pop this out, I get a result. I pop this out, get a result. Yeah. So this will be the solution for the problem. Now let's get back to the coding. For easy calculation, I'm gonna prepare this stack with a -1. So this is just for easy calculation. If I would to pop out the last one, if there's nothing, I'm gonna use 0 minus -1. I got a 1. I can calculate the area. And for this height, I need to plus a 0 at the end. This is just for, yeah, maybe at the end I still need a 0. If it is lower, I need to pop all that out to check the result. I also need to prepare the length of the height array. Let me check. Do I need that? Maybe not. Yeah. Now let's just start coding. So for I8 in enumerate the heights, I'm gonna prepare the stack structure. So while length of the stack more than 1. This is because I've already put a -1 inside, so definitely it's gonna be the length of 1. If I put another 1 inside, it's gonna be 2, and then I'm gonna start to check. If it is more than 1 and the height is less than the let me check. Yeah, the height with index of stack -1. Yeah, if it is less than, it means if it is decreasing, it is not okay. I need to pop out index. So it's gonna be the stack dot pop out this index, and then I can calculate the result. So I'm gonna prepare a result as 0 because I need to calculate the maximum. So it's gonna be the maximum of result. Now I pop out index z. So for example, this is a 2. It is a decreasing. So if it is a decreasing, so this index for this 2 has popped out. Yeah, but I need to have the index from the one position before it. So it's gonna be it's gonna be z -1 before it, and I also need to minus the stack -1. let me check if it is like this. So yeah, here is my I pop out yeah, I need to use this z. If I pop out this z, z minus 1 would be here, and yeah, my stack minus 1 is here, so the distance should be 1. Let me explain it. Yeah, so if I have a 2, I pop out the index for this 2, and now I use z minus 1. I need to point it to this one because I want to calculate the area of this one. So z minus 1 and then minus stack minus 1. So because this one has popped out, z has been popped out, and the stack minus 1 would be here. Yeah, let me check. Should I use I should use I, not z. Yeah, because z is basically the stack minus 1. So I need to use I. Yeah, so currently my position, so for example, my position is at this one. So this is my I, because from here I checked something wrong, it is decreasing. So my I minus 1, I'm here. Yeah, but this is z equal to stack.pop. Yeah, it means I don't need to use this z. I stack pop, it means I pop out this one, and then I use stack minus 1, it is here. So this one minus this one, it is 1. Yeah, it should be okay. Yeah. After that, I need to put the index inside of the stack. So it's gonna be stack.append this I. And finally, I need to return the result. Yeah, let me just check if there's something wrong with it. Yeah, so this is a index, and this is the distance. So the distance should times the height. So it's gonna be the height of the z. Yeah. So z, I popped out this z. Z is here. I need to use the maximum height. Currently, it is here, and then it's gonna be here. Yeah. I think this should be okay. Now this is why we're going to use this z, and because we need to times this height z. Now let me run it to check if it works. Yeah, maybe I need to copy the link, and from here let me try to check it from here. Yeah, now let's analyze the time complexity. So if it is a monotonic stack, so the time complexity would be O(n). So here is a while loop. Actually, we just need to push the value into the stack and pop it out. So it is a n times 2. So the time complexity would be O(n). Yeah. There's some error. Now let me run it again. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. And thank you for watching. See you next time.